Hello and welcome to the video series on the True of Go exercise walkthroughs. Today's video covers the 8th exercise, rot13Reader, from the Methods and Interfaces module inside of the Methods and Interfaces chapter. Rather than just showing you my solution directly, I will explain all the necessary Golang concepts and context for you to impart with a deep understanding of what each and every single line of code really means. A common pattern is an io.Reader that wraps another io.Reader, modifying the stream in some way. For example, the gzip.newReader function takes an io.Reader, a stream of compressed data, and returns a pointer gzip.reader that also implements io.Reader, a stream of the decompressed data. Implement a rot13Reader that implements io.Reader and reads from an io.Reader, modifying the stream by applying the rot13 substitution cipher to all alphabetical characters. Rot13 stands for rotate 13, and it's a simple algorithm which shifts each character in the alphabet by 13 positions. The Wikipedia article is linked here, but all we really need to understand is this image right here, where we either shift a letter up by 13 positions or down by 13 positions. The rot13Reader type is provided for you. Make it an io.Reader by implementing its read method. As mentioned in the exercise description, the type rot13Reader is provided to us as a struct. It has a single field named r of type io.Reader. Inside of the main function, a value of this type is constructed, where the inner reader r is a strings.newReader, which holds some encrypted text string. Lastly, it's making a call to io.Copy with the file pointer os.standardout and a pointer to the constructed reader. Copy simply calls the read method on the source io.Reader and then writes that data to the destination, here standard out. If we take a look at the type definition of io.Copy, it actually takes an io.Writer interface as the destination and not a file. io.Writer is basically the complementary interface to io.Reader. The core idea being that it's just a thing we can write to. In our case, it's the file for standard out, and the file type natively implements the writer interface. But it could, for example, be any other kind of writer, like a network socket or an in-memory buffer. Now, when we run the code in this starting state, we see an error method in line 16, so for the copy call, essentially saying that rot13Reader does not implement io.Reader as it's missing the read method. We'll be working on that. Okay, to summarize, our goal is to make rot13Reader an io.Reader by implementing the read method, where we take the output of the underlying reader and shift each alphabetic character 13 positions, and hopefully we'll be able to decipher the text. Alrighty then, let's give our rot13Reader a read method. Func rot pointer rot13Reader read b slice of byte returns an int and error. We will first call read on our inner reader. So rot.r.read, pass in the byte slice. The read call returns two values, just like we are returning now. First of all, the number of bytes read, and second, an error if there was any error. So we'll get n and error. Now, usually when we call a method or a function which returns an error, the Go idiom is to check if the error is not nil. So like if error is not equal to nil, then we handle it. However, it's possible that an error occurred in the middle of the read, where some non-zero quantity of bytes was actually read into the byte slice B. If that's the case, we still want to apply the rot13 cipher to those successfully read in bytes. And then we pass up the error to the caller, who can then decide how to deal with that error. So let's apply the cipher to every single read byte on the underlying reader. So we'll go for I in range n. And we'll set b at I equal to rot13. We'll implement this function in a second. B at I. Okay, and then after the loop, we will return n as the number of bytes read and pass up the error. Now let's create the rot13 function, which is rot13, takes in a byte b, and it returns a byte. So the idea for this function is that if the character is in the first half of the alphabet, we'll add 13 to the byte. And if it's in the second half of the alphabet, we'll subtract 13 from it. And if it's a non-alphabetical character, like a space or an exclamation mark, we'll return the character as is. Okay, so let's start by checking for the first half of the alphabet. So B is greater or equal to lowercase a, and B is less than or equal to M, or B is greater or equal to uppercase A, and B is less than or equal to uppercase M. Okay. Now, if that's the case, we'll return B plus 13. And now we'll do the same thing for the second half of the alphabet. So I'll just copy this for now. And B needs to be greater or equal to N, and less than or equal to Z, and greater or equal to uppercase N, and less than or equal to uppercase Z. And if it's in the second half of the alphabet, we'll subtract 13. Now, if neither of these conditions are true, we will simply return the character as is. All right, so we've given our rot13Reader a read method, which calls read on the underlying reader. And then for every single byte read, B gets reassigned the shifted or rotated new byte via the helper function. Now, when we run this code, one thing I'd like to mention is that we've implemented the read method as a pointer receiver rather than a value receiver. If we were to use a value receiver here, so removing the asterisk, the entire struct, including all of its fields, are copied when calling read. The code still works, and it's not a big issue with the current underlying io.Reader, but we could imagine a scenario where the underlying structure is quite large, or we often call read, which would cause this copying overhead. So with the pointer receiver, the method is working on the struct reference and avoids the copying overhead. And that's it for this fun little exercise. Hopefully you've gotten something out of this walkthrough. Thank you so much for watching, and I'll see you in the next one. Peace.